Chapter 4, example number 3. Data for car rental companies for a previous year is presented in the following table. Company name, cars, revenue. First question, make a scatter plot. How do we make a scatter plot? First, we need to identify dependent variable, also known as response variable, and explanatory variable, also we call independent variable. Revenue depends on number of cars. Therefore, revenue is dependent variable here. We use y. Then cars is independent variable. We use x. Then we go to the xy coordinate system. We always use independent variable on x-axis. Here independent variable is cars. It is on x-axis. Dependent variable always in y-axis. In this example, it is revenue. What is the first point? It is 63, that is the x. Then y is 7. This is the point 63, 7. Second one, 29, 3.9. So this is the point 29, 3.9. Similarly, you can complete this scatter plot. Once you complete this scatter plot, you can see the direction. What is the direction here? This data is spread in this direction. So this has positive relationship. This is in positive direction. What is the positive mean? When x increases, y also increases. The second one, find the correlation R step by step. First, write the equation for this example. How many points we have? We have 6 points. 1, 2, 3, 4, 5, 6 points. So, I write the equation for the 6 points. R equal 1 over n minus 1 and x1 minus x bar over sx, y1 minus y bar over sy, multiply those two, then summation, then x2 minus x bar over sx, y2 minus y bar over sy, similarly up to 6 points. So this is the equation for R for this problem. So what do we need to find now? We need to find x bar. We see we need x bar, y bar. Those are average of x and y respectively, and sx and sy. Those are the standard deviation of x and y respectively. So I explained how to calculate average and sample standard deviation. If you cannot remember, please go back to my previous videos. You will understand how to calculate them. I already calculated. So x bar is 25.63 and y bar is 3.12, sx is 19.58 and standard deviation of y is 2.12. Now let me consider this table. In the first column, we have x data. Second column, y data. So third one, we need xi minus x bar over sx. Right. The first one, x1 minus x bar over sa. What is the x1 now? x1 is 63 and x bar is 25.63 and sx is 19.58. So this equal 1.909. I leave this for 3 decimal places. 1.909. So second one, x2 minus x bar over sx. So x2 here 29 minus then x bar the same like 25.63. The standard deviation is 19.58. So this is 0.172. So you can write down here 0.172. Similarly, we can fill the rest of the cells in this column. Negative 0.247, negative 0.334, negative 0.625, negative 0.875. Now go to the next column. Here we have yi minus y bar over sy. So let me explain that part for the first observation. 1 minus y bar over sy, y1 is 7 here, minus y bar is 3.12 divided by sy 2.12. So this is 1.834. 1.834. Similarly, we can write the rest of the number in this column: 0.319, negative 0.482, negative 0.151, negative 0.813, negative 0.766. The next one, we need to get the multiplication of these two numbers. Yes, you see here the last column, x1 minus x bar over sx time y1 minus y bar over sy. 1.909 times 1.834, 3.501. Next, 0.063, 0.119, 0.050, 0.508, 0.670. What is the next step? Next, we need to get the summation of these numbers. You see example, once we have the multiplication of each terms, then we need the summation. What is the summation of the last column? Summation is 4.911. Then go back to the equation. R equal 1 over n minus 1. How many observations? 6 observations minus 1, 4.911. Then answer is 0.9822. Let me explain few things here. What is the range of the R value? R always must be less than or equal 1 and greater than or equal negative 1. Here R very close to 1. Therefore, we can say this x and y. X is the number of cars, y is the revenue, and x and y has very strong linear relationship. But sign is positive. We also saw this positive relationship in a scatter plot. Therefore, we can say x and y has strong positive linear relationship. Here, linear is very important. Why? R explain only linear relationship.